Namaste. In the class, we will discuss about a global position system. What's a global position system? A GPS. All are familiar with this, we know that, right? What is GPS? Okay, GPS is a satellite-based system which helps in fixing the position in XYZ plane on the Earth's surface as well as in the near space. Okay, GPS is commonly used for navigation. However, in the recent years, GPS has a wide range of applications in the civil engineering, military, etc. We'll know little about the history of global position system, right? The Navstar GPS and GLONASS satellite navigation system developed by USA and Soviet Union respectively during the Second World War for navigation purpose, for military purpose. Then European Union also added one more GPS system known as Galileo, and we have our own GPS system, right? India has our own GPS system, Indian Regional Navigation Satellite System, IRNSS, also known as NAVIC, okay? Navigation with Indian constellation. Okay? Then, however, we are depending on Navstar GPS and GLONASS GPS because you can get it has wide range of application, right, globally. The Navstar GPS and GLONASS satellite navigation system offer global civil community continuous high precision position and timing service anywhere in the world. That is why most of the people still prefer Navstar GPS and GLONASS. That means there are various segments in the GPS. There are three important segments in the GPS. There are space segment, user segment and control segment. We will talk about each segment. Space segment, it includes 24 satellites. Okay, they are orbiting around the Earth in 6 different orbital planes. Right, there are 24 satellites orbiting around the Earth in 6 different orbital planes. That means in each orbital plane there will be 4 satellites. Okay, the orbital plane of these satellites inclined at 60 degree with respect to the equator, and this orbital planes arranged in such a way that at any time, right, there should be signals from 4 satellites available for a person anywhere in the globe. Okay, these space segments, the satellites continuously sends time coded radio signals, right? The sends radio signals, they are time coded. Yes. Then we have a user segment, a user receiver. Okay, it's a simple GPS receiver. That this receiver receives the time coded radio signals from the satellites and measures the distance between the satellite and the GPS. Okay, the signals from 3 to 4 satellites are very essential, at least 4 satellites very essential to fix the position of the GPS receiver in anywhere in the globe, on the Earth's surface or in the near space, right? You can fix your XYZ position, right? To control, there is another segment called control segment. The control segment controls or monitors the health of the GPS satellites. The altitude of these satellites are nearly 24,000 kilometers, 22 to 24,000 kilometers above the Earth's surface, and the satellite sends time coded radio signals. These signals received by the GPS receiver to fix their position, and sometimes the health of satellites, the time or error due to the atomic clock present in the satellite, the accuracy of this is 1 second for 30 years. High accurate atomic clock is present in the satellite. However, sometimes there will be some errors or the movement in the orbital plane, slight movement can induce the error. To monitor this error, there is a control segment. There are a master station as well as control stations and ground antennas to monitor the health of the GPS satellites. If there is anything wrong, that the control master station sends the signal to the satellite to repair that, okay, like that. And what are the various applications? Yes, this GPS has a wide range of application in civil engineering, okay. The first and foremost is GPS application in surveying. Right, GPS based data collection is much faster than the conventional survey. Okay, that requires manpower and equipment, labor, etc. Then GPS application in geodetic surveying. What means geodetic surveying? The geodetic surveying considers Earth as a curve, the curvilinear feature of the Earth. You know, in conventional surveying, we imagine Earth as flat surface, but in a geodetic surveying, we consider the curvature of the Earth, right? For this, the conventional, it's highly impossible, right? In the case of conventional surveying, but in the geodetic surveying is can be done effectively using GPS surveying. Okay. Okay, you can high degree of linear and angular observation can be achieved by the GPS application. Another important thing, the GPS application for study of geodynamics. What do you mean geodynamics? You know, the earth crust is in continuous movement. The conventional currents, the magma drives earth crust. You know, all earth crust is moving in a specific direction. One should understand the direction of movement of earth crust, the speed of that, very important to understand, predict the earthquakes as well as the seismic properties in that area, right. For that, one should clearly map the direction of movement of the earth crust as well as the speed. GPS helps greatly in this area.